Welcome back to another episode of Freeform AI. My name is Michael Burke, and I do data engineering and machine learning at Databricks. I'm joined by my co-host. His name is
Ben Wilson. I refactor my messes at Databricks.
yeah, and build startups within Databricks.
Not
Today,
for real.
yeah, today we're going to be talking about that exact use case. We're going to be talking about how do you build with the modern Python stack with Gen AI. So we've talked a lot about how to leverage things like Claude Code, ChatGPT, etc., to make your products better. What if you actually want to use LLMs as the agents or the engines within your products? Well, they're non-deterministic, they can hallucinate, they're messy. With modern Python, you're able to create guardrails around potentially chaotic probabilistic generation goblins and enforce contracts. So, Ben, why did I use the term chaotic probabilistic generating goblins?
I think that's because I just said that a couple minutes before we
It
recorded.
is, yes.
And that's what they are, man. They are, it's like a toddler, right? That is like a very advanced toddler that has a mastery of human linguistic communication, but it has the temperament and the ability to hold a lot of instructions in their head that's very similar to a toddler. You have to consistently tell it, don't touch the stove, get out of the kitchen. No, don't pick up that knife.
Mm-hmm.
Like, stop hitting your brother. You're constantly having to like tell it like not to do these certain set of things. And the more things that you process in a single command to one of them, the less they're going to pay attention to. Like, they're well intentioned. Don't get me wrong. But if you try to tell it, hey, do these 40 things and don't do these 120 things in one massive prompt, good luck. It probably won't do all of those things. And that's just due to the nature of how they work. You're not talking to a sentient being that can process things. You're talking to something that's just generating the next probable token from what the input was. So loading too much stuff into it without even checking to see what's coming out of it, that's one problem. And that's like an architectural design discussion of like how to properly interface with LLMs. But what we're talking about today is if you just take what its output is at face value and be like, yeah, just give me a string, man, or give me a dictionary of strings, and then just vibe on. I'm like, yep, I'm going to take this, pass this to my next stage. And then it'll do like some stuff. It'll like see if the data's there. If not, we'll use some fallbacks maybe. And then, yeah, we got an output we can just give to the user. You've just created a room full of chaos goblins just running around, touching everything, breaking everything. You have no idea what's going on.
Yeah, crystal clear. And as LMs become the engines of more and more systems, we need to be able to create systems that can guard against this chaos and actually leverage LM outputs in a stable manner. So this is going to be a bit more of a technical episode, and I would love to just sort of rapid fire what you think the current state of building with modern Python and modern Python packages alongside leveraging LLMs, because software has solved this sort of strongly typed contract based development a long time ago. But this is sort of new in that non-deterministic systems are entering as a essential and foundational component. So yeah, I think we can just kick it off from there. But first things first, what the hell is a contract?
It's a way for you to say to your system and anything that interacts with a subsystem within that, here's what I promise truth looks like. It is a strongly typed collection of data, a data structure. It's like, I'm going to pass in something that I know to be of a certain structure into a function. And then what comes out of that function is a particular shape with particular types of values within that. What happens inside your function, it is what it is. It can be a couple of lines of code. It could be calls to 37 other different functions through some nested hierarchy of complexity. But at the end of the day, you know what is coming in and you know what is coming out. And those are the contracts that are being made to callers and callees in order to make your system just even marginally understandable.
And the way that I think about it is they're connection definitions. So when you're linking up two train cars, it's the hooks and the structure that's needed for the hooks to actually work, or it's a lock and a key, or if it's steps in a recipe, it's what the prior step will produce for the subsequent step. It's the connectors themselves. And as Ben said, it can be data types, it can be names of variables. What are some other software concepts that are often applied in contracts?
I mean, other concepts, it's basically just the typed foundation and the structure of what it is.
So that
You can
involves
have,
like integers, booleans, whatever. That's like the data type of the field. It also defines the field structure. So if there's three fields called Michael Ben podcast, then they will be present. It's nullable, whether they are guaranteed to be present or not. Also with validation, how does that work? How do we know that when I create or instantiate an object, the variable themselves are actually going to adhere to that spec? Because Python is duck typed, not strongly typed, right?
yeah. And what I see in certain code bases is people doing that validation inside the function itself, where it's like, hey, I get this data in, maybe it's a dictionary of any type. And then there's just all this code that's like, get this value. And then right below, it's like, if value is of type this, then do this. Else if it's this, do this. That is like pure chaos distilled into that function. Because even if that's the one place that it lives and it's part of like a call stack, the minute you add anything else to that code base, that is another parallel path for that to do, or there's some caller stack that has to like interpret the output, that dynamic output. That's now a variant, right? It's like, I don't know what this could be. You now have to replicate that logic or that decision logic elsewhere in your code. And that's how you create code that's like, hang on a second, what's going on here? I have how many parallel paths that could go to how many parallel paths that could go to how many parallel paths? It just creates way more state knowledge than a human brain can contain when just looking at the code. That now means you can't maintain that thing. When you get a bug or like some weird behavior, you just kind of shrug and be like, hope that doesn't happen again. Or let's patch that. And then you realize an hour later, oh, there's this other weird thing. I got to put a patch in for that in 7 different places. So your code base just starts expanding exponentially in order to make it meet quality standards. And then you're going to hit a point where you're like, I can't reason about this anymore. And I can even ask Gen AI to assist with reasoning about this, and it gets confused. You're now in danger zone. So what you do, instead of embedding that conditional check logic in a function call, is you put it into a class definition. And that class, that contract definition of like, this is when an object comes out of this, when I create that object before returning it, all the validation exists there. So everywhere that is going to be using this contract, it all gets the same treatment. I know that an integer is expected here. It's supposed to be here. And there are libraries that you can use that just do that validation for you. So you don't even have to write that code.
Right. So, philosophical question then. If we're going to be leveraging classes as the validator, and if upon instantiation we know that it's valid, how do you go about defining what valid is? How do you know your contract isn't too constraining or it's too wide?
I always start locked down and keep it there unless there's a compelling reason for me to deviate from that. So a good example would be, well, I call this like structured API for service A, and it like returns this one, this one key in the JSON that is named something, is named like BB. But then service number 2, it returns that same thing as BAB. And you're like, well, it's the same data, but it's just named differently. Maybe I just do that reconciliation within that one object because it's simple. It's like, oh, I'm just renaming a field that I know is the exact same. And I just have validation logic that's like, make sure the value of this key matches this pattern or is a string. Keep it simple that way. But if it's structurally different, if it's like, okay, this one API has a nested structure in it where like this metadata is like 2 layers deep and is like completely different than this other API, that's a whole different contract. You can have both contracts return the same structure, but the internal logic of how to get to that final state can be different. So now you have branching logic in a handler that's like, if coming from service A, return this type of class. And both of those classes, and then if service level B, return this other class. But within those class definitions of both of them, the return types that they're returning are identical and are an instance of another object that you're creating. Now you're creating like a sane type system where you're like, okay, I don't care what comes in. I handle whatever nonsense comes in, but the rest of my code sees this one structure.
Okay. I have like 10 trillion questions that I've been writing down actually. Because this is something that I've struggled with so hard, and I think it's challenging with the complexity and velocity of Gen AI based development, especially when you're using tools to augment your development. So that makes sense. So you are suggesting that when you're passing or creating contracts, you want them to be as locked down as possible. Um, can you give it, this is still sort of a bit fuzzy. Can you give a tangible example of something you've built, let's say in the last month, where you've opted for a more locked down contract than an open one?
What I dropped last night is locked down. And that's contract boundaries at every single function call site.
Wow.
Everything.
And how is that implemented?
Painfully. So that was like re-architecting the entire implementation, which some of it was like, hey, I don't really know what the state of this return is going to be. Or it's like, hey, I'm telling an LLM to just do this one task, like detect language. And I'm expecting like an ISO 2 version of the language to come back. Totally fine. It never broke. It was just accurate. And I'm like, yeah, it's fine. I'll move on to the next thing that I'm working on. Because that was the feature that I was supposed to be doing, was like allow for language to be applied to an email. Like do translation, but do like natural human translation, not what you get from Google Translate. And what I rapidly realized with that was it worked 99% of the time. But as I was doing volume testing, it just snuck through. It just said French instead of FR. And that got interpreted correctly by the translation layer because it was another LLM call. But then as I'm doing more testing, when I was doing stuff where I was like feeding in additional information for references, emails were getting generated that were multi-language. It was like, okay, everything in this is French except for these 2 sentences that are in English. What is going on here? And it turned out that the reference layer wasn't able to understand what the word French was because it was looking for a 2-letter code, and the exception was being eaten. It just wasn't. It was like, whatever. I'm just going to skip that stage and not translate that. So I was like, okay, this is how bugs are created, and this is how bugs evolve, because I can't even see this happening, defaulting to fallback logic, and now the output of the system is unstable. So I went back and looked at the interfaces and was like, yeah, no wonder this is doing this. Like, I don't even have a contract here. So I just created a data class that's like, this is what the shape of this should be, and put a validator in it. It's like, it must be only 2 characters long. If it fails, recall, like make the call again, back to the original LLM and insert an additional line in the prompt that's about like, hey, you just messed this up, go do this correctly, make sure there's only 2 letters. And most modern LLMs, when they're told that they did something wrong, it usually resolves itself. But I could only get that with that contract in place and that validator.
Got it. So what exactly did you use as a validator? Like, did you build your own? Did you use Pydantic data classes?
For almost all of the external facing ones, it was all Pydantic.
Cool. What is Pydantic and why did it evolve?
Pydantic is like a plugin system that extends the base concepts of Python data classes in a very, very clever, very nice way, such that it's easy to just leverage built-in validators where you can like define a field, define what type that value should be, and Pydantic will check it for you. And then you can extend certain things where you're like, I'm expecting this number of characters in this string, or I'm expecting this number to be formatted in this way. There's so many things you can do with it. It is an insanely powerful library that I dearly, dearly love. So yeah, you get all this stuff for free. Other people built it. It works, and you can use it really easily.
So to be clear, if I add type hints to my function declaration, that does not enforce the type.
No, not in Python. Typed languages, most certainly it will. And you will get a very stern warning, either at compilation time or at runtime, about why you just violated this invariant. But it's very obvious what happened, and you're like, okay, this is not a float. This is an integer. Got it. Let's change our type system here.
And you've done a lot of
Python will just pass that through. It'll be like, don't care.
And you've done a lot of strongly typed dev with Scala. You've also done a lot of duck typing with Python. I'm curious, which do you prefer? Like, what is better in your brain? And is it just use one in one scenario, use another in another scenario? What are the trade-offs?
I'm comfortable with Python these days by a large margin, but I can still read and write Scala and Java. It depends on what you're doing. So if you told me like, dude, you need to rewrite everything you just worked on in Java, I would tell you to go pound sand. Like, no, I'm not doing that. That entire system that I built would probably be 6 to 20 times longer in number of lines of code than what it is right now, with no real benefit. It would just be cargo cult engineering. We need to make this in Java. Like, why? It doesn't need to be portable. We know where it's running. Like, it's not like we're going to run this on a refrigerator. Like, why do we need this in a portable, like, compiled language? It just doesn't make any sense. So there are benefits to strongly typed languages that I wish Python had it internalized, but there's so many external packages now that provide assurances for this type of stuff. And then with the advent of like Pydantic 2x, it's like, this solves a lot of the pain points. So I don't have to type all of that validator logic in a base Python class. It's just sweet.
That makes a lot of sense. Okay. So sounds like Pydantic is a great option for strongly typed languages. It extends data classes. What the hell is a data class?
It's basically just syntax sugar over a class that extends a bunch of properties that make it easy to do common operations that you would do for a data containing class.
And it's a name tuple, right?
I mean, name tuple is another, I think that was a precursor to data classes, but people didn't really like it that much, myself included. Like, I've written name tuples before. I'm like, yeah, it's cool. But data classes give you like a cleaner container with better dunder commands that are available. So if you need to do something a little bit more advanced, it's just easier to manage. The underlying data structure is like very similar though.
I actually thought it was a wraparound name tuple, but it is not. Good
it's
to
like a
know.
new implementation.
Yeah. Okay. Yeah. When I typically think about this, I feel like Pydantic is a better solution if you need robust validation. It just has such a strong validator structure Then data classes are good for sort of static or simple configs. When would you use that versus an enum in Python?
I mean, if you look in that ludicrous PR that I just filed, there's enums all over the place. So if I need to do like a resolution of a keyed value in code to like a constant, and I want to restrict what is available, enums are perfect for that. Like, here's the available values that you can use. Anything else is not valid. And then here's what they resolve to. That's perfect for an enum. It's simple, no nonsense. If I need to do something that's like, here's just a basic interface for conversion between like this data structure and this other one, I might use a protocol. It's like, this is just the over the wire contract for how data is passed. It's really clean. It's really light on memory consumption. It's fast to execute. It's perfect for that. It's like the simple version of it. But if I need to do validations and I need to actually add helper methods to something, that's where a data class really shines. Where I'm like, I have a data container, like a data class, but I need to cast that in another place to this other type. I can put that as a method that's like def to this other object type and have the conversion live with the data definition. So I keep all of that like serialization, deserialization logic in one place in that class definition, just so I don't have to put it in like another module and like create a function helper to do that for me. It's like, why? Just create a method.
Okay, that makes sense. Cool. So we're starting to sort of outline the different structures you can use in Python, some of the built-in and external packages. I would like to brain vomit some struggles that I've had throughout the past several years. So when I first joined Databricks about 4 years ago at this point, I had theoretically written a lot of code, but I didn't have much software engineering background. I did study it a little in school, but I also did fail out 3 times consecutively. So I didn't get that full computer science sort of backing of the fundamentals of algorithms and data structures. So since then, I've treated being on the job as an amazing opportunity to learn this in a way that works for my brain, which is actually solving real world use cases instead of doing everything for a letter on a piece of paper. No offense to school. And throughout this time, I feel like I've learned a lot, and some of them were via a kind of annoying and hard route, but it has really seared it into my brain, unfortunately, or fortunately. Wouldn't do it again, but glad I have it now. So one thing that I've struggled with is when I was contributing to ML, or I think this was actually Unity Catalog's open source AI plugins. I remember I was really struggling to get my head around complex function signatures. So specifically with LLMs, there's this sort of this, and this is pre there being a very standard like OpenAI based protocol. There were a bunch of different response payloads. So I don't remember the exact ones, but let's say Crew AI had its own, Light LLM had another one, OpenAI had another one. And when I would go in, and a lot of them were actually very poorly documented, you just had to look at what the code does in that open source package, infer it, and go from there. So we were building plugins where we would integrate with that response layer, parse some of the stuff, patch some of the stuff, do something, and then basically continue on. How do you think about quickly grokking complex signatures that are maybe not well documented?
I do it probably the hard way. I don't know. I hit it and I look at what comes back. And then I change what I'm hitting it with and I look at what comes back. If there's no documentation for it and there's no source of truth that I can rely on, I take those tests that I do and I just write a contract. And if that contract breaks while I'm testing other things, then I know there's this weird thing that can happen in this case. But I'm not trying to expand it out to be, I will accept anything and everything, and then I will try to resolve it to something that's meaningful. I will accept what I will accept until evidence proves otherwise, that my model is flawed. And then I add an exception for that or like modify it slightly. I think that's the only sane way to do something like that.
So I made that exact mistake where I tried to accept everything and then parse it, and then when something was unparsable, have a friendly error message. Where do you draw the line between it is the sender's responsibility versus your code's responsibility to adhere to an undocumented contract?
It's always your responsibility. You can never, ever rely on an external service to just play fair because their incentives aren't aligned with yours. They might be they might include something in a payload that was a mistake and you built a model around that. And now you're now like having to deal with their bug that they introduced, or it might be an unstable API that you're interfacing with and you accept anything and everything. You're building all this logic to parse all of that stuff instead of just drawing a line in the sand and saying, this is version 1. And if they change some stuff, that's now version 2. And we conform to that new one that we can verify through evidence. That's a way to keep that contract. Like the version allows for mutation, but you're locking it down at certain points and saying, I'm not going to play this game of like trying to read your minds like through the internet. Like you're never going to be successful with that. You can be, but you're going to expend a lot of energy trying to do it.
Yeah, 100%. Basically, you cannot guarantee that there won't be breaking changes from a third-party service, no matter how good or stable they have been in the past. You just got to sort of program defensively. That makes sense.
And
Another
contain
question.
that chaos at the edge.
Exactly. And that's a boundary of your system, right? And so you want to ensure that whatever actually enters your system adheres to your contracts. Another one, state machines. So a state machine is basically the state is an object that sort of gets passed around through the machine, modified, and then used. So the classic one is LangGraph, where it actually has a state object, and it could be messages, it could be like current node, next node, or any other criteria that you have for routing. And it can just be passed around in sort of this arbitrary or theoretically arbitrary fashion and doesn't necessarily need to adhere to a specific contract or scheme. I remember when I first started doing ETL, or extract, transform, load, which is data engineering conceptually in Spark and Databricks, there was a big config file. And I would just basically instantiate a data class typically and pass that data class around so that all of my functions only took one argument. It was that state. And then it would pull 3 of the 45 arguments that was needed for that process, then pass it on to the next one and pass it on to the next one. So that sort of works, but it's also kind of, I don't know, it doesn't feel right these days now that I've built it a few times. And it's also very inefficient and error prone. So
yep, I would agree.
One of the very obvious things is unit testing. You have to reconstruct that full state object. But how do you think about when to use a state machine as a contract versus a very concise function signature?
For someone who has actually built a state machine from scratch for, as you mentioned, Unity catalog, I avoid those things like the plague. There are so many things that can go wrong with them. And the one that I did build that is stupidly complex, it was scoped into the only boundary that it was actually maintaining state was a Python document, like function document contract. That's it. It used AST to read the actual source code of a definition as it existed in memory and use a state machine to parse the different components of a doc string. And that was, I think it was like 2,700 lines of code to build that thing. And it is the stuff that nightmares are made out of when you look at how complex it can get. So I avoid stuff like that on like just general principle. If I'm building an application, there's no need to do that. And you nailed most of the points where it's like, how do you inspect the state at this point of time? Now I have to build like a super complex logging system where I'm just replicating an object in logs 1,000 times for every request. Like it's stupid. Do I trace it? Well, what are you tracing? Are you tracing like the inputs and outputs to a stage, or are you tracing the actual config object that's moving through and how it's getting mutated? Now your traces look absolutely stupid with like all of this metadata that's being replicated for each thing. How do you make sure that the meta, like that state object, all of the data in there isn't sensitive. Like, is it holding onto an API key? Is it holding on to a config to access your system? Like, it's plutonium, man. Like, and there's so many things that can go wrong with just the debugging process of that. You're signing yourself up for production hell. And particularly when you start like manipulating that thing, you're like, oh yeah, our demo works cool, but our users are asking for these 17 features. How do we plug this into this? Is this config object for all of these different features that we need to add? Is this now becoming pages of text on a screen? It's like there are better patterns for this. So
Yeah,
I'm not a fan.
agreed. All right, next question. So, and maybe more of a statement than a question, but let's take this argument as far as possible. We want validation for every single thing in our program, including every single variable declaration. So that means every single variable in my entire Python program is a Pydantic model with a validator that gives it a type and, let's say, a range. That's probably a lot of work and hard to read.
I
So
would agree.
So one of the amazing benefits of Python is the not strongly typed nature of it, but also the fact that functions are first-class citizens. You can pass them into a function, you can make them objects, and a variety of other things that leads to a lot of flexibility in Python. So when do you sort of relax this traditional software strongly typed mindset and leverage things that are more Python?
I never relax it. I just don't use Pydantic everywhere. Pydantic objects, they're super powerful, but I don't need all of that overhead if I'm calling module A from module B. I already know what that interface should be. However, I don't allow that communication to be like an untyped dict, because now I don't really know what's going on internally in my program. So when I need, like I do when I build it at first, and that's why, as we were talking about, that abomination got created, because I just started patching more and more features onto this thing without really thinking about how unstable am I making this. And then moving from that to, okay, this stage of this application, like this feature within this application, it's doing the following three things at its core. It has to assemble a prompt to give the LLM an instruction set. It has to go and execute that, like call the LLM with the data payload that it needs in order to do its job, and then get that back and validate it to make sure, do I need to do anything? Like if the LLM loses its mind here, is this a risky state? Like, is this going to break the pipeline? And do I need to retry it? Or do I have like a safe fallback I can use? So those three components are like the essentials for each of these things. But between each of those stages, I'm not calling them sequentially from within that module or within that directory structure. They're actually calling out to different services, like other subsystems within the program. So to get a prompt, that's calling a prompt compiler. And that prompt compiler gives information from its code in a structured way, so that I don't have to wonder, like, for each of the 13 stages of this pipeline, am I just getting like a random dictionary of just nonsense with like keys and values of the data state, and then having to like repeatedly check for keys and then check for values, make sure that it did what it's supposed to do at each of these different stages of the application. I can just say, here's the contract, and within that contract I have validators to make sure that you know the data that should be there is there, and that the types are correct, and any optional values are either there or they're not there. So that at the consumer part of like, hey, go build my prompt for me for this stage based on all this conditional logic, that's two contracts right there. I have the one that's going out and I have the one that's coming in. They're just consistent. So I take all of that complexity and remove it from that surface area. So all I'm worried about is data transfer between one subsystem to another. And it's consistent. So it's like the same call with different data, every single place that we do it. So if in 3 weeks you get that ticket of like, hey, Michael, like our customers that are using this, like they really want these 3 changes to be done. And you all of a sudden realize like, we need another pipeline stage. If it was the jumbled mass of spaghetti it was before, you're now having to go through and like basically reverse engineer my thought process while slapping mud on an ever increasing ball of confusion. Now you can just be like, that's all I have to do is just like create these 3 files to do these 3 things and then just put the logic where it belongs. This is pretty simple. Okay, I'll go do that.
Yeah, it's so self-documenting. Types are absolutely essential when thinking about programming, and Python allows you to sort of not require that. And so type hints at a minimum are super, super valuable, but adhering to object-based contracts like that, or having functions with single sets of responsibilities where you know if something comes in, it's going to take these 3 forms as an output, then it's a lot easier to wrap your head around it. So that makes a lot of sense. I
Yeah.
have,
And it's cleaner code too.
yeah,
There's
yeah.
nothing uglier than input.get name of key, comma, fallback. And you see that like 80 times in a function. You're like, dude, why does this exist? When
Yeah.
this could just be like a single object that you're using dot notation access to get the attributes. And you don't even need to do validation then. You're just like, I know it's this type.
Yeah. And in Python 3.11, they introduced the walrus operator, which makes you do like 7 layers of nested walrus operators if you have that access pattern. It's really fucking ugly.
But yeah, I
Cool.
mean, it's a code smell, right? When you see
Yeah.
that, you're just like, this is haunted. Like,
Mhm.
we need to exorcise these demons.
Yeah. Yeah. I'm just like, I don't like it. Whatever it is, get rid of it.
This
uh,
hurts my soul.
cool. Final targeted question before one general question. So for the modern dev stack, I think at least at FDE at Databricks or forward deployed engineering, we've aligned on some really great standards as defined by Niall, who's one of our principals. And he's very smart, thought about this a lot, and built a 100-page manifesto that is actually pretty good and should stand the test of time generally. Obviously, software evolves very quickly. So the modern stack that we have subscribed to is UV for Python package management. It's actually really freaking awesome. Additionally, Astral-based linters. So Rough is the classic one. Pydantic is really powerful for validation. Enums are really great for constants in Python. What else would you recommend as like the modern Python stack?
I mean, single constants as uppercase references, definitely use that.
Mm-hmm. Yeah,
Implementive.
and not just
Okay.
style as well. Like, so of course, underscore for private methods, not underscore for public methods. But beyond like PEP, whatever the like number is after PEP, beyond Python style, what are the modern, let's say, development practices that may have been popularized in the past 3 to 5 years that you would highly recommend people use when building Python-based LLM systems?
I would definitely, for people who are just getting into this and are like either coming from an ML background, getting into app development, you're getting into software engineering when you do this. It's not like, oh, I'm dealing with a model now and I can kind of be fast and loose with like the data is more important than like the code is. Invert that in your mind. Like the code is particularly for things that you're trying to build and all of a sudden you realize this is going to become complicated. Like there's a lot of moving pieces in this, or the problem that we're trying to solve is actually complex. Start looking into like basic design patterns that are proven and just fundamental concepts like how do you inherit something correctly? So if you're connected to 3 separate services that are all kind of similar, but they're not exactly similar, but you know that you want to simplify decision logic of like which one to use at which time or how the code just looks accessing these things. Look at inheritance of like, okay, I'm going to create an abstract base class that has like the same, like these 3 core methods that are going to be used in everything. Define them once and then create concrete implementations for the 3 different ones that are going to inherit from that. So you don't have to like repeatedly implement the same thing over and over. Keeps your code lighter, more consistent, it's easier to test, and it's just less lines of code for you to have to worry about. That's a big one. And think about composition, about how does the code actually define what its logical train is as it's moving through it. Some big anti-patterns I see are things like you have the main God method or the main function that it does all the things. Like it's the access point, and all it's doing is just calling hundreds and hundreds of different functions. Abstract that stuff away, like build into like separate modules that separate all of those concerns away. Because the moment you have all of your logic embedded in a single function, and now in order to test all of that, you have to actually call that one function, and you need all of those services working. You need very good logging if you're going to do that, and to be able to just understand what the heck is going on. So submodules make it so that each one is like, okay, this is your job and this is your only job, and I can test that you're going to do that one job, and I don't have to worry about you blending that logic into other stuff. And contracts help you do that.
Sold. All right, final question. Do you have general tips? Let's say I am a AI engineer, whatever they're called these days, and I'm building product X with LLMs as an engine. How should I go about it? Anything general? Any pieces of advice?
Don't put control flow logic into a prompt. The LLM doesn't know how your program is supposed to work. It doesn't care. It's not even alive. It's not sentient. Like, it's going to make decisions that you are not ready to deal with the consequences of. And it might work when the program is simple. The minute you start adding additional complexity where you're like, okay, now I have like decisions that need to be made. Like, if you see this in the data, then do this, else do this other thing. Good luck, man. Like, it's going to start infuriating you. And you're going to think like, oh, my prompt's just not written well enough. Maybe I need to change the order of operations in the prompt. If that's hitting you in your brain pan, even just a little bit as a hint of like, oh, I think I just need to like optimize this prompt and like how it's laid out, you're doing it wrong. That is, you're now putting too much complexity into one stage and relying on some magic alien intelligence to just read your mind. It cannot, and it doesn't understand like what the heck it's supposed to be doing.
Yeah, I think
Them simple.
the toddler analogy hit super hard for me at the beginning. It's like, if you give a kid one simple instruction, the kid will probably do it relatively well most of the time. You want guardrails so it doesn't go set the house on fire or burn its hand or whatever. But if you give it a dictionary of instructions, it is going to fail at all of them spectacularly. So LLMs are sort of similar. They're very counterintuitive in how they operate from my perspective, but they're also very intuitive in other areas. So it's not like talking to a human, but there are aspects that are the same. And I think context and how humans treat context, they're actually very, very similar. So that makes a ton of sense. And then my miscellaneous tip is use tracing. I know this is sort of a shameless plug for MLflow tracing or just a tracing system in general, but having async timestamp based logging and monitoring with inputs and outputs is really freaking invaluable for these non-deterministic systems. If you have this chain and it goes and does something weird, you want to be able to reproduce the state of that chain at any given point in time, and that's what tracing offers. So please employ that. All right, I will summarize. So today we had a more technical focused episode about modern Python programming when we're leveraging Gen AI systems as the engine. A contract is a definition of truth. It's typically strongly typed and validated. Within Python, you can enforce contracts in a variety of ways, but there are some standard Pythonic practices, or you can actually explicitly enforce them. But some things to call out: enums, use them as constants. It's really helpful. Data classes are sort of a lightweight data object that you can pass around, and then use Pydantic if you need more robust validation. And a few miscellaneous tips. When defining a contract, start locked down and open up cases as needed. When interacting with third-party systems, code defensively and ensure that whatever enters your system is adhering to the contract that you specify. You cannot guarantee that a third party will adhere to their contracts. And then third, logically abstract so you can unit test and be dry or don't repeat yourself.
Yes.
Anything else?
Nailed it.
Sweet. Until next time, it's been Michael Burke and my co-host,
Ben Wilson.
and have a good day, everyone.
We'll catch you next time.